Hello, and welcome to the chaos that is my mind. Today I'm going to be sharing a space travel design that I thought of, although I'm not an aerospace engineer. I'm not sure how well it would actually hold up. Before we begin, if you have a fear of math, you probably wouldn't like this video. It's a lot of math and science. Or if you don't like people being nerdy, which not sure why you would feel that way, but if you do, you'd probably not want to watch my channel at all. Now, this design isn't exactly complicated, but it does cost quite a lot. How it works is alpha, beta, and gamma particles from the sun hit an almost sail that's made out of lead, and I think that them hitting the lead sail would propel the ship forward with its momentum. Let's first think of a sail that is 500 by 500 feet, or 152.4 by 152.4 meters. According to the Australia Radiation Protection and Nuclear Safety Agency, alpha particles often go 5 to 7% of the speed of light, or 0.06 c, and are essentially 4 protons, so weigh about 6.68 times 10 to the power of negative 24 grams, or 26.72 micrograms. Also, according to the Australia Radiation Protection and Nuclear Safety Agency, beta particles are electrons, so they weigh the same, about 0.015 micrograms, but they can reach near light speed, but I couldn't find any exact number, so I'm just going to assume that it's 0.85 c, or 85% of the speed of light. Now for the one I'm very excited for, the gamma particles. They go the speed of light, and no mass? Pure energy? At least it has kinetic energy that can be transferred. Yay. Now we have to calculate the force of each of the impacts. So for a single alpha particle hitting the sail block thing, it would generate a whopping 1.34 times 10 to the power of negative 12 joules of energy. Yay! A single beta particle can also generate 1.33 times 10 to the power of negative 13 joules of energy. I can't really calculate the kinetic energy of something without mass, so I'll just pretend there's a speck of dust caught in each gamma ray. But with that, a single gamma ray with a speck of dust can generate, on impact, 0.045 joules. That is massively different compared to the others. And although it is a speck of dust, which is a lot bigger than the others, but still. I also couldn't find any information on the average spread of particles, so I'll just assume that there are 1 billion for every square meter. This is an assumption, not even an educated guess, but it's better than just giving up. I'm starting to notice that there's a lot of assumptions. This is probably a gross understatement, but for 1 square meter, alpha particles can generate 1.34 times 10 to the power of negative 5 joules, and 2.03 times 10 to the power of negative 3 joules for the entire thing, which is far less than I thought it would be. For 1 meter of beta particles, it's 1.33 times 10 to the power of negative 6 joules, and for the entire thing, 2.02 times 10 to the power of negative 4. Again, less than I thought. But now for the gamma particles. For 1 square meter, 45 million joules? And then for the entire thing, it's 6,840 million joules. That is way more than the others. Emitted particles don't even matter at that level. I was going to add them all up, but I'm just going to do the gamma ray particle things, kinetic energy. All that hour of math was pointless. But anyway, now we just need the weight of the ship to be able to figure out how fast the kinetic energy movement. I need to wait to end this thought. Transition! The density of lead is 11.94 grams per cubic centimeter, so it's also 11.94 hectograms per cubic meter. And the ship weighs in total 1,819.65 hectograms, or 181.96 kilograms, which seems low. According to Northwest University, it takes 9.8 joules to move 1 kilogram 1 meter. So that means it takes 1,783.21 joules to move the ship 1 meter. And so with a single flat layer of particles, the ship can move 3,835.77 kilometers in an instant. Now, the whole reason I designed this spaceship is because I want to send my friend to Alpha Centauri because he wants to remove all shapes. But to get that, we need to find the speed per second, so I multiply the current speed by 1 billion, which is probably still an understatement. And that gets us 23,262 astronomical units per second. That means it only takes 14.5 seconds to get to Alpha Centauri. There's no way a human could survive that. Even with a single square meter, it only takes 30.32 minutes. That is incredibly effective. Too effective, even. But thank you so much for watching to the end, and if you did make it this far, please subscribe. Corny YouTuber and English.